started right away. This is a bit of a longer presentation, so we're going to use all the time that we have. My name is Darwin Alarcon. I am the club president of the West Wyoming Tech Club, and today we're going to be doing a project showcase. So before we jump into the technical aspects of our project, I want to quickly go over why we chose to do the project we did. So when we got together at the beginning of the semester to decide what we wanted to do, we agreed upon three things pretty quickly. Number one, whatever we did had to be really applicable to future jobs or future projects or future classes. So teach us a lot of cool things. Number two, had to fit the interests of our club. So within our club, there's a lot of members interested in more of the hardware aspect of computer science. Some are interested in more pure software development and programming, and others more interested in just pure web development and websites. And so we had a lot to juggle. And lastly, we had to do something that was actually achievable. So we didn't want to get stuck halfway through and have to push it to next semester, especially because a lot of our members would be leaving after the semester. So we wanted to do something that was definitely achievable for our given time frame. And with that, we landed on a little Arduino card that we could control over the internet. And we ran into a few problems, but we were able to achieve it within our time frame. And the main concept driving our project is something known as the Internet of Things. And so it's an idea of facilitating communication between hardware, software, the cloud, and other hardware. And so when you turn on your car with your phone, that's Internet of Things. When you check your Ring camera with a website or your laptop, that's Internet of Things. And so we thought it'd be a really nice tool to learn and would really help us out in the future. And so let's jump into our project. So when you look at the concept, it's really not that complicated. It's just, okay, I push a button on the website and the card moves forward or backward and so on. But I think as you can see from the overview of the project, there's quite a few steps to it. And so pretty soon when we started on the project, we realized that we'd have to get pretty in depth into getting this thing going. So I know that right now this diagram doesn't make a lot of sense, but our goal is that by the end of this presentation, this diagram will make complete sense. And so this presentation will be split into three parts. The first part will be the entirety of this right-hand side of the diagram, which is the website side of our project. The second part will be the hardware side, which is the bottom part of this left side. And the last part will be the software side, which is the top part. So with that being said, let's start with the website. So when a user first enters our website, they are first prompted to enter a password. And assuming they enter that password correctly, they will be able to actually interact with the website and start sending commands. So they can press forward and they can check to make sure that their command actually went through. So on the front end of the website, it looks pretty simple. But as I'm about to show you, the back end is a little bit complicated. So as I said, when the website first starts up, it really needs two main things. Number one, how do I get the password that I need the user to enter? And number two, where do I send my commands to? So how we deployed our website, basically, we've told the website, all right, if you want to get those two values, you can go to this configuration file, which is basically this file right here. Within this file, you can find both of those values, and you can import it into the website. So when you look at this file, you can find that the IP is right here, and this whole entire long string is an IP. So it looks a little bit different than your usual IP, and we're going to go a little bit more into that in a little bit. And down here you can see that the password is just password, which isn't great for security, but it works for now. And what the website can do, it can go to this file, pull out these two values, and actually import them into the website. So in this first block, it imports the IP as an environment variable, and it does the exact same thing for the password. So the important thing to note here is that both of them are imported as environment variables, which means that if in the future or while the website is running, we want to change the password, we want to change where that website is pointing to, so give it a new IP, we can change the values in this file without having to redeploy the website, which makes it a lot more seamless and a lot less complicated to work with. And I also want, and before I move on, I also want to note that I did not work on the website. That was done by one of our online members named Patrick. And so I had him sit me down in a call, and he just explained this entire process to me. So I want to give huge props to him. He was the main driving force behind this. And so, all right. So now that we know how a user can get into the website, what happens when the user actually presses a button? So before we jump into the actual code, let's just do a quick overview. A user presses down a button. This detects the button. It translates into Go. And eventually, all this code just outputs this little thing. This is what is eventually sent to the car. Just this tiny string is sent, and we need all this code to actually do it. So what does this code actually do? So on the HTMX side, this is actually doing the button detection. So within this top block and this last block, it is detecting when the button is being pressed down. And when this button is being pressed down, it is triggering the Go part of our program. So what the Go part does is say, okay, what button was pressed down. So let's say that this time it's a forward button pressed down. Okay, now that I know that forward is being pressed down, where do I send it to? Within this part, it will say, okay, I'm going to find the IP I need to send it to, which we've established in the last slide. It can find from the file, and then it will use those two things to send this to the given destination. And then within these two middle blocks, we have a listening division. So essentially what these two blocks will do is when the user presses down the button, it sends a forward command. But we want to listen to the moment the user lets go of the button to send a stop command. So it imitates a press and hold kind of feature. So the moment the user lets go of the button, the car will stop moving. So we can imitate that without actually implement that into the button. And with that, that is basically the entirety of the website side. So I will hand it off to Antonio.
Thank you. And so I'm going to share a little bit about the deployment and DevOps side of this, because there's a couple pieces that have to land together in order to go from, hey, we wrote some code on our laptops, to I've got something deployed on a car and deployed on a website that other users can access to drive the vehicle. And so I'll spend a little time talking about the process that we used to go from we have a program that works to we have a website that's running and we have an app deployed on a Raspberry Pi that can drive the car from that website. And so both of these diagrams show the two different processes we used to essentially move program from computer to program on a website and program in the car. We'll start with the website side first. And in both cases, we stored all of our code in GitHub. So we did our development locally, and then we pushed up to GitHub as just a repository to store any of the programs that we put together. And for the website, we have some cloud servers that are running where we have some automation in place that when we push things up to GitHub, it picks up the code, deploys the website, and then refreshes whatever you're seeing when you go to the website domain name. And so that's pretty straightforward. And we have actually a few different versions of the site running right now. One that's optimized for mobile, one that's running better on desktop, and then a sandbox that we use for testing. So when we roll out a new feature, we don't break production. We can test out the feature in our sandbox, make sure it's good, and then promote it up to the other environments. On the IoT side, rather than having something running in the cloud, there's like a physical car with a physical server that's running that is interpreting the commands that are coming from the website. And so that deployment process is a little bit different. Sort of started in the same place of code's in GitHub, but in order to get it to a physical device, we essentially just connected to that physical device locally and then copied our code over to get it running. And so those are the two real pieces of the software that we're using to both offer the control plane on the website, but also have the local IoT device running the software that we built. Awesome. So that's our automation piece, and I'll hand back to Darwin to talk a little bit more about the hardware.
To have a better idea of how exactly we get commands to the car, we're going to go over how the car will use those commands to actually translate it into movement. So within the hardware aspect, we can really break it down to three main parts. So the first part will be the power, which we power the whole entire car using a Raspberry Pi hat. So within this Pi hat, we have two 1860-50 batteries, which for our use is quite a bit of juice. It translates to about 2 hours of use. So kind of overkill, but allows for a lot more addition in the future. And so that sits right on top of the Raspberry Pi, which of course is the brains of the actual car. And so this Raspberry Pi is what's actually receiving all the commands. And so when the Raspberry Pi receives the command, it will say, okay, I will use the power from the Raspberry Pi hat, which sits right on top of me. I will use that power and send it to the motor driver, which is right down here, this red guy. The motor driver will translate that power, which from the Raspberry Pi hat is straight 5 volt. And I will make that power usable for our electric motor wheels. And that is essentially the entirety of our aspect, broken down pretty straightforward. So here's the actual car itself. So when you look at the configuration we have, the Raspberry Pi hat sits quite literally right on top of the Raspberry Pi. And that sits right on top of our wheelbase. And now we can go a little bit more into the wiring. So this big loop right here on the right is essentially the on and off switch for the motor driver. So that goes loose right here and right into the motor driver. So that doesn't actually control the commands being sent to the motor. It just says, is the motor on or off at all. This tiny loop over here on the left is what actually is used to send commands to the motor. And this is what will be used to say, hey, I want this specific wheel being turned on or this specific wheel being turned off. So going off of that, a really important concept in this part is known as GPIO pins. So within the Raspberry Pi, these pins are numbered. And so what I can do within my code is say, if I want, let's say, pin 13 to be powered on, I can, within my code, call pin 13. And when I do that, pin 13 will be powered on, and it will send current all the way into the motor driver. And that will correspond to a specific wheel being turned on. So we can say pin 13 will correspond to wheel, the left wheel turning on, or pin 14 will correspond to the right wheel being turned off. And so that is how we actually get communication from the software being translated into actual physical movement. So now that we're going towards software, I'm going to hand it off to our Vice President, Nicholas.
All right. So I'm going to go over the software side of the car, the actual code that I worked on. So if you paid attention, some of the variables and that we had actually referenced in Arduino app. And when we very first started, we were using an Arduino. However, we had some issues with the Wi-Fi chip communicating with the Arduino. We could have maybe gotten it to work, but that was more hardware side, and we were lost at that. So we decided to switch to the Raspberry Pi since it had the Wi-Fi chip built into it. And in order to do that, we also had to switch our code a little bit to Python, as Arduino was C++ code. And so with the car code, we had 3 different things we needed to start to have it all run. So we had a shell script that would execute all of those all at once to automate the process and make it a lot nicer than having to go into the CLI and basically execute all of those 3 commands. And getting into this, we could make remote connections to the car through SSH or VNC. VNC is more like the desktop GUI, where SSH is the command line interface in Linux. And so we broke up the class, or the code, into separate classes. This made it a lot easier to test, as the car code had imports that would only work on the Raspberry Pi, where the server class we could test separately. And the server class's job was listening to the GET requests that would be sent from the website to the local server running on the Pi. And in order to do that, we needed to use ngrok to tunnel the connections to make it accessible to the website. And with ngrok, it did change the IP a little bit. This is a typical IP address you may see, whereas the ngrok is more a domain name. And then it also had a port at the end that was separated by the semicolon. And then we also used a router for the Pi to give it a static IP, so we could always know what the local IP was for making the remote connections to the car. Finally, we have the motor control class. This is the car class code. And its job was to control the GPIO pins for the motors that it would get from the server. And then we had a PWM, which stands for pulse width modulation, to control the speed. And it basically pulses the pin on and off to achieve an average of the voltage you specify. So normally GPIO pins have a output of 5 volts or 0 volts, which is on or off. With the PWM, you can achieve voltages between those, but it's the average, not a static voltage. With the higher voltage, making the motor go faster. And it is what receives the commands from the server. And so this is just a example diagram of the pulse width modulation and the timing of it turning on and off. Right? And so with that, I'm going to pass it back off to Darwin. Oh.
Should hopefully make a bit more sense, but I'm going to do a quick overview again to explain a general lifespan of a GET request. So a user will get onto the website and they will have to enter their password. And on the other side of the website, we can change a few of the settings and also change where the website is pointing to, and also change the password ourselves. So a user will, of course, enter a direction. This will be translated. This will be detected with HTMX and translated with Go. In order to make the jump between website and to the car, we have to use ngrok to get around any of the firewall issues. So that's what ngrok helps us out with. Now we can actually get to the server class on the car. This server class will be used to detect that GET request, hand it off to the motor control class, which will then translate that request into actual hardware movement, which will translate to real movement on the wheelbase. And so that, in turn, is the whole entire cycle of one button push. And so yeah, now we can move on to the actual demo and moving the car. So Nicholas is gonna show a little bit of the setting up of that. I'm just gonna get in here and pull up that SH thing. So, all good to go? Yep.
Alrighty, so this is basically what the command line interface looks like.
Yeah. This is what we have to do.
The command you can execute to get in is the SSH, and then you have the user and the IP address. And when you execute that, it asks for a password to get in.
This is essentially what we have to do every time we want to start the car.
And then we're going to change directory into the car folder. And if we list the contents, these are sort of the Python class files we were discussing, with this start.sh being the shell script. And so we would then execute the shell script by running the /. And when that's executed, it will run them in screens, and so we'll have all of these files running.
Yeah. This guy just tells us that everything's running okay. Detached means that's good. Yeah.
And so we can basically look at them. So the first one was the ngrok. If we go ahead and do screen-R, we can see the ngrok side looks like with the IP that's forwarding. Yeah. And then we can detach to it, and we can actually look at the main program too. And this shows you the logs of all the GET requests that the server received to control the car.
So with that in mind, we can actually start controlling the car. So this is what the user will see, of course. And like we said before, the password is password. So now the user is set to actually control the car. So essentially, press forward, car goes forward. The moment the user lets go of the button, the car stops. And it takes a lot to actually get this pretty simple thing going, but I guess that's how software development is. So if you ever wondered why there's so many software developers, it's because to get this, to do that, it took a team of about 5 people. So yeah, if somebody, I guess, wants to come up and push buttons, they're free to do so. And yeah, that's it. So before we end, I'm going to do a little bit of shilling. We are doing a fundraiser at the moment to raise money for next semester. So if you thought, oh, that's cool, I want to build a car of my own, you can enter for the chance to win. It's $5. And, or if you just want to help out the club, you can also enter. And yeah, there you go. Yeah. So yeah, if somebody wants to come up and actually press the buttons, they're free to do so.
Yeah.
See how
You can also do it from your laptop.
see the tolerance on it. Yeah.
The site.
Yeah, the way we set it up is any website or any phone can just log onto this website and try it out, assuming you're not on Ethernet. But yeah.
So how many lines of code actually went into?
Probably 90 for the server class. Was it also 90 for the motor control?
Please repeat the question for the mics for outreach.
Oh yeah, so they asked how many lines of code was it for the software part of it. So now going into the website part of it, what's on the car is 90 for the server that's running on the car, 90 lines I think for the hardware controls. I don't remember how much is in the battery status. Battery status is around 30, I think. When it comes to the website code, I think that was around 300. So yeah, I mean, like I said, we had a team of people,
Yeah.
and everybody copies code. So, yeah, you can go off examples and whatnot. If any other questions as well.
So what are your guys' individual plans? Because you said a couple of you are graduating and moving on. What would you like to do next? And what do you hope the club does next year?
So in terms of the club, I'm going to be gone, but we're hoping to, at least I gave them an idea. So we're hoping that we could get some suspension on this thing, hopefully get it 4 wheels instead of 2 wheels, get a Pi camera on it, which isn't actually too complicated, and eventually I get it to like a Mars rover kind of thing. So you could get this thing a lot more off-road capable. So maybe try it out on the trails over by the college here. So yeah, just trick it out a little bit more. Yeah. In terms of individual stuff, I guess all the members have their own interests and whatnot.
Any other questions?
Was it a big switch to go from C++ to Python, or was that like totally starting over, or was it?
They're pretty different programs, but I wish we did it earlier. It's easier for our case, yeah.
The question, was it a big switch to change from C++ to the Python
Yeah.
program?
Uh-huh.
I translated that. It wasn't too bad, but a lot of it was taking out semicolons
Yeah.
and curly braces that C++ uses that Python does not use.
Mhm.
So what's the actual voltage for those batteries? Do you think 12 volts DCs still, or is it?
Each of those batteries does 3, but when they're together, the whole entire thing outputs 5 volt.
Okay, so it's 5 volt system.
Yeah, 5 volt system. Mhm. Mhm. Yep.
When it came to you routing your IPs, you said you just used a router. Was this just like you went to the Walmart and picked up a router, or did you use like a program instead to just use a static IP?
Yeah, so the question was about the router
So
that
we
the
have-
car.
Yeah, like it's a little travel router that it just connects to that we're running it off of.
Mhm. Yeah, because when it's off the school Wi-Fi, oftentimes the Wi-Fi will just go on and off, and it'll completely switch the IP of the car.
Right.
Mhm.
Yeah, so the school Wi-Fi has a DHCP which dynamically assigns IPs, and we never could figure out the IP. So using
Yeah.
the router allowed us to have control of the IP assignment, so we knew
Yeah.
what the IP of the car would be.
Just one less thing to worry about.